also, or have numeric test. So we have seen the numeric. In the same way, we also fill the missing text. So suppose I have 4 or 5 missing text in graduate or marital status, yes, no. So you can also fill in the same way. Now, if I want to handle means I have to convert the numeric data to, sorry, not the numeric. I want to convert the categories data or categorical or text data to numeric. Now here is my most handling task, most handy task to do. Now there are multiple things. How? First of all, you can also go for label encoding. There are multiple process. Then we have dummy variables. And we have label maps. And at the last, we have one hot encoding. This can be termed as. Now, what is the main issue, main thing? The main is thing we will be moving by dummy variables. How we actually create a dummy. What is basically dummy? Now, in order to understand dummy, we have to go with a very simple example. Now, I will be coming to this particular sheet where I have defined this particular categorical form of data. Now, how will I be saying? I will be saying, suppose we are 4 friends. I am taking my 4 friends to Bangalore. Okay, and suppose we are boarding Rajdhani Express from New Delhi to Bangalore. Now, I have made reservation of my friends on my own, and I have made them into sit in different classes. Now, in that particular train, I have 3 classes, and I have 4 friends with me. So, suppose my data of my 4 friends is something like this. That is my A friend, B friend, C friend, and my D friend. And the tier they are sitting, that first is in first class, second, third class, and first class. Now this is a numerical data. Machine can easily understand numerical data. I'm not giving it as, I'm giving it as first. Now on the second point, I'm not giving as, I'm giving as second. And the same way I'm providing as third. And this is as first. Now machine cannot understand this point. If I want to convert this data to numeric, I have to confine my data in a very specific format. So what I will do, I will make the dummy for my each data variable. Now this point of thing will come. Now here I will say first, second. Okay, now when I will read the data that my first friend is in A, the dummy variable for these particular column will be or can be mentioned like this. Now you can also say this as not this. So I will be replacing, or I will be replacing this whole matrix in the transpose of this matrix. You have to take the transpose, not in this format. You cannot take this in, no, cannot take in this format, but first you have to transpose this. Let me transpose this. Delete it first, and I will write my friend A, B, and C, and here I will write first class. I will write first, then I have second, and the last I have third. What happened when I say my first friend is in first class, then it will say in the first class his value is 0, and at the last and third is 0, 0. When I say my B is in second class, so in first class he is not present, he will be sitting in second class, so it will say 0, and at the last what it will say 0 up here also. Now when I'm saying I have my friend in of C is in third class, so in first class he is not sitting, in second he is not sitting, in third he is 0. Now if I'm saying about my last friend that is in first class, so I say first 0, 0. Okay. Now, can you see I have transformed my this data which I have up here with me to a numerical format. What numerical format I can define? I can define that I have transformed my data into numerical format. Now that process or that thing can be understood as formation of dummy variables. Now each category will become a separate column in this. Now you can see that here we have different categories regarding that. Now what happened in dummy variable, we basically create, or when we create dummy variable, we basically forms each category for the column. But in R, we have a very specific type that we can easily convert or make these dummy directly into numeric columns. and what this particular data or this particular thing or how it actually works. So we will be looking at that point how it actually works. So let me have that point how it actually works. So now I will be saying that suppose I want to convert. Now what are those my category one? So first, if I want to see the category one, we will find that in data I have job type. And if I want to see the head of this job type, so I will say head means top one, top some data. So I will be coming up here and I say control enter, and you can see that I have top one in which I have categories. Now suppose I want to convert this into numeric format. So what I will say data. Coming up here, I will say that I will make another column. I will add another column which will contain the numeric value for this column. So I will say I have job type, and this I will come up here and say underscore employed and assign this with as dot numeric. I will convert this as numeric value. Which column? I will say data job type double equal to employed. So this way I can create a sample dummy in this particular job type column. Now what happened, where I will get employee in the job type column, it will convert that particular to numeric value. In the same way I have to convert for all the columns which I will be mentioning about. I will say data. So in order to reduce my sum work, I think I have this particular with me some or the other way. Just a second. Okay, so let me take that only the file. Yeah, fine. So I have one of the file. So I'll be taking that particular file. I will be copying this. I'll be coming to my main file, which are where we were actually working out. So I'll be going to paste, and you can see I have converting the job type columns to numeric, to numeric, marital status where it is Y to numeric. Now you will find that I have only done for three columns. Here is the fourth one. Here is the fourth one. I have not defined. Na fourth one I have defined only for unemployed, employed, and retired. Where is the student one column? Now, when we are saying we are going into dummy variable, so we will say we make total dummies of n minus 1. Now n is total number of categories. So when you find what are the total number of categories in that, so how you will find total number of category, you will cite data within this job type. Okay, now previously when we have seen the categories, we have seen that we have seen this particular categories as unique. So I will be coming down up here and I will say I will find the unique. Within this unique, I will find the job type. And within job type, when I enter, I find that there are four categories, but I have made dummies for only three. Now, where is that particular fourth one? So the rule says that we only make dummies for n minus 1. Why n minus 1? Let us have a quick example for that. So now if suppose I say I remove this particular column, if I remove this particular column, how many categories I have in this? I have three categories, but I have only made dummy for this. So what directly it indicate that if suppose I don't, if suppose my friend is not sitting in first class and my friend is not sitting in second class, then directly or indirectly he is appearing to be in the third class. Now that is a concept why I am taking or why I am making only three categories and removing or not entering the fourth categories. Understanding, my machine will understand. Suppose if in a data we have a student category, then when we will directly say that here what we are saying that here we are taking three categories, and when all the three categories are termed as zero, it will automatically occur in fourth category. In the same way, when I am coming for marital status, I have only make for yes. For marital status, I have only defined that particular column for yes. I have not defined for no, because individually or indirectly when I say yes, no will automatically get indicated. Same way for secondary, Same way for education grade. In education, I have three categories. I have only made for two, and in the same way for metro cities. So when I'm going to run all these, when I'm going to convert all these, you will find that these columns will be going to add up in my data. Okay, now let's have look at the data. So I will say call names. I will find into data. So you can find that I have all the columns name which are being added by me. So you can say job type underscore employed, unemployed, secondary. And if you want to see the actual data, you can also find directly click on data and say enter. And you will see that I have all the form of data. On the left hand side, you will say that I have multiple columns. So you will say, okay, no, but I want to see a very confined form. So you can directly say view data, control enter, and in the left we will find that yes, you have added some of the column. So you have converted the job type as unemployed. So where is unemployed? In unemployed we have 1, and on the retire it has 0 and 0 in the left. On the same way we have converted those numeric columns to, sorry, those text column to numeric. Now when I'm going to do some sort of regression or some sort of analysis, I will not take these values into consideration, these text value. So first of all, if I want to do some sort of analysis, I have to first drop those values. Okay, so how we will be going to drop those values? So how we will drop those values up here? We will be saying data. I will be assigning this as data. Within this, I will add minus C. I want to drop the columns. I want to drop which column? So I will coming up here and I will view, again I will view this particular data. Now here the column number start from 1. 1 is age. I want to drop second, third, fourth and fifth. So coming up here and I will write from second to fifth. So I will write 2, 3, 4, 5. So when I will say drop this and then again I say view of data, so you will find that we have just dropped these text column from our main data. So when I click this and I click this, you can find that yes, I have dropped all the text column from my data. So now I have all this data, age, since, last date, purchase, job type, and so on. Now, if you are going to analyze this, you have basically cleaned the data. Now, your task is to pre-process also. Now, pre-process can include multiple things. First of all, now suppose I would like to toss an example up here. Now, suppose coming up on this particular Excel file, let's have a quick one of the example. Now, suppose we are 5 friends. Okay, we are 5 friends, and I have a data of my 5 friends, which are A, B, C, again D, E, F, something like this. And I have a salary or I have a some sort of income level with them. So this is it, this is it, this is it, this is it. Now what happened when somebody was entering his data, he had entered this particular value. Okay, this particular value. But according to me or according to my data, my all 5 friends don't have income above 3,000. I don't, my all the friends don't have their income in the level above 3,000. Now, if I don't have the income above 3,000, what will happen? If I take the mean of this, now just try to see the things. If suppose I try to say that all my friends, in my friends, we have a mean, and I say mean, or I can say average also. I find that my all friends average can be something like this. Now this and fine. You will say that their average is 25,000, but is the average correct or not? क्या ये जो average है वो हमारे लिए correct होता अगर मैं analysis कर रहा होता? I will not say yes. Why? Because one of my friend have a very large range or very large value which is fluctuating the actual result. Now this particular value, can be termed as outlier value. Now, outliers are what? These are those values which occur rarely in data that can make our analysis bias, or I can make my result bias towards one side. For example, if I say that we have all the average, means we all spend or we all earn 25,000 per $25,815 or bucks per month, that is not correct, because maximum of my friend has only a salary less than 3,000, but one of the candidate who has more than 1 lakh has fluctuated the overall result. So the same way we have to first treat the outlier. So here we will see outlier treatment. Now, how we will see the outlier treatment? Outlier treatment can be understood in this particular format. Like, if you want to see the outlier, you have to use box plot. A box plot. Now, how we will say box plot? I will say box plot. Acha. Which column are being used to see the outlier? Outlier is basically seen continuous form of data. Now here I will say up here and I'll say I have data within age, I have continuous. When I click on this, you can see box plot is available up here with me. Now within this particular box plot, you will find some sort of data. So I am going to save this image as, I'm going to save this image, just a second. So, or this particular box plot, I'm going to draw this particular box plot somewhat around here. Okay, so just let me rub this. Fine. So suppose I have a box plot which is just similar to that. Let me draw a box plot. Okay, I think this particular thing is just resembling this particular thing. Now, what actually box plot is acting or behaving, that it is saying that it is a maximum value. It is saying that this is a minimum value. And this is the median value from where I have divided my data into two parts. This is the Q3. This is a Q1. And these points are my outliers. Now these points can be up also, can be down also. Now these few points are which are above the average values or the median form. So now I will term this M as an outlier. So the values which are above maximum or minimum below, now they are termed as outlier. And in the block you can see we have some outlier and we have to treat. Now you will say what percentage of outlier do we treat? Now one important question will come to your mind. Okay, what percent do we have to treat? What percentage of outlier do we treat? Now, there are three similar cases. Now, there are three cases which you can follow. First case is the percentile. Somebody says you can cut off 4 to 8% of outlier. I have not followed this particular rule. The second one says use interquartile range. Now, what is interquartile range? Interquartile range basically means that suppose you are when you are dwelling in this interquartile range, I can define interquartile range as Q3 minus Q1. Q3 minus Q1. And what is Q3 minus Q1? This particular data. So I can use interquartile range to define this particular maximum value and minimum value. How we actually define this interquartile range? So we have a very fine formula for that. So let me drag that formula up from here. So I have defined this particular formula from here. So I'll be using the IQR formula. How IQR is defined? First of all, we will state the summary for this particular data in age. So when we see the age summary, we find that the minimum value is this, the maximum value is this. I have Q3 as 44 and Q1 as 33. So I have defined Q1 value as 33 and Q3 as 44. By defining this, I said that IQR interquartile range is Q3 minus Q1. Means I will be exploring the 50% of data. So I will be saying the IQR value, I'm getting the IQR value. if I'm saying what will be the maximum upper limit to take the outlier and minimum upper limit to take the outlier, so it is given by this particular formula, that is Q3 means the quartile third plus 1.5 of IQR. In the down, we have Q1 minus 1.5 of IQR. So when I'm going to run this and when I'm going to run this, I have a value of lower range for taking outlier and upper range for outlier. So for lower value, I have LL, and for upper value, I have UL. Okay, when I'm going to print UL, what happened? I got upper value. Upper value is 65. So what I will say from this particular data, I will say any value, which is less than 60.5, any value which is less than 60.5, it is okay. And any value which is greater than 60.5, we will compress the value of that value to 60.5. And how I am going to compress the value, let's see. So we will be coming back. We will coming back. How we will going to compress the value, because before compressing we cannot. So let me have this. Fine. Coming up here. Okay. Now what I am doing, I am saying in this particular data age column, if else means we are using if and else condition, where my data is greater than 60.5, I am using this out upper limit value, compress that value or make that value 60.5 in the column of this. So when I'm going to run this and when I'm going to see the box plot again, you will find that the all the outlier has been treated. Now this particular format can be used to treat the outliers in data. Now this is the most significant format, that each numerical column should be treated or should be outlier treated, because if we don't treat, then our data can become biased toward one point. Now I have another form. I will say box plot. In box plot, I will say data. I have another numeric one, that is which is in continuous nature, that is since login since last days. Now this is also up there, so I'm going to run this. You can find that there is outlier, maximum outlier in the bottom part, so it means I have to remove these outliers. So what I will go, or how I'm going to remove these outliers, I'm going to copy this. First of all, I have to take this value as this also. So I will copying this as copy. I'll be doing this as this. Now I'll be not taking this age, I'll be taking this as sign in days. I'll sign in days. Now I'll be taking this sign in days as this. I have to change the value, so I'll be taking the first quartile is 73.0, last quartile is 92, third quartile. I'll be saying control enter, control enter. Fine, Q1, Q3 as there. Upper limit, lower limit, I have defined, they have changed their value. So when I will be saying, say I have to define lower limit, so I'll be coming up here, copying this, pasting this, and I will not say age, here I will be defining this since last days. If the value is less than what? If it is less than the lower quartile, that is 44.5, express or expand to 44.5. In which data? In this particular data, that is since last days. And here also I have to change this data as dollar since last days. Perfectly fine. I'm going to run this. No issue at all. So I will be saying dollar since last days. Control enter. Fine. You can see I have just removed the outliers. Now this is the pre-process and cleaning part of outlier treatment. Now there are multiple ways which we can have outlier treatment regarding multiple things. Now in this particular data, we will find that we have converted all the columns, all the things to numeric. So let's view the data, and we have cleaned the outlier also. So let's find the data, and we will find that we have cleaned all the data. There is no missing value. There is no categorical value. There is no outlier. I have treated the data. Now, when my data has been pre-processed or cleaned, now I will be moving down towards the point where I was saying about. Now, where is that point one? So let me come to that mainframe. Yeah, this point. I was here for machine learning because our major two topics are being still left, that is linear regression and logistic regression. Now, where I'm talking about linear regression and logistic regression, I have to first talk about machine learning. What is basically machine learning? So machine learning is basically, I was saying that machine learn from data and try to predict or figure out what has happened in data, try to figure out the facts, try to figure out the patterns, try to figure out the important points which a machine could learn from the data and try to figure out on a new data which is provided for the machine during testing. Now, if I'm talking about supervised machine learning, here machine is trained under supervision and the outcome is already known. What it means? In supervised machine learning, we want to say that the machine which is trying to predict something is already know what it has to predict. For example, if I say that tomorrow is going to tomorrow we have a going to be a match between India and Pakistan, so we know that there is the outcome of winning and losing, or we can have a draw or we can have a super over. We know what will going to happen in future. In another case, suppose we have a data of a customer of different sort of category. Now I don't know which customer going to get more discount or which customer will get or going to have less discount. So now there, when my machine, now here machine takes its own decision and the outcome result is not known. Now here we can understand that. Now, in supervised machine learning, if I'm talking at supervised machine learning, so supervised machine learning has been divided into two sequel parts. So I can say first is called regression and the second is called classification. Now, here is a major case study where people used to get confused and to implement what. Now here is the major question. Many of the people around the world don't know when to apply regression and when not to apply regression, when to apply classification or not. So the basic answer lies in the part that what is the case study. Now what is the case study basically? Now if I'm saying about supervised machine learning, and if I'm talking about regression or classification, so what is my case study? Now here also there are two things. Suppose I will take a very basic form of regression and a very basic form of classification. There are two case studies, so you will have a comparative measure. What is that and what is what? Now classification. Now if I'm saying about regression, suppose I have a very small data, something like that. Now I have age and I have salary. Okay, now this is my data. So I will not take up here a classification or control X. I'm going to paste up here. Now fine. So suppose I have a date. Suppose somebody's age is 20, 18, 20, 22, 24, 29. Now fine. I'll have a salary about something about 18,000, 20,000, or 2020. Let me take 20,000, 25,000, 29,000, 34,000. Now okay, now I have very small data set with me of age and salary. Now here you will be able to find or you will to analyze that in this particular data, what happening that suppose I have this, I want to make prediction based upon age. Suppose a person age is 27. Now what will be the salary for this particular person? Now I want to analyze for this particular condition. Now, when you are saying that you have this age and you want to predict the salary for this, now basically you are trying to figure out a relationship between age and salary. Okay, now if I'm saying regression, so I can directly say regression is basically a statistical technique which figure out the relationship between a dependent variable and independent variable. What is dependent variable and what is independent variable? The major thing is that now, if suppose I take a very small example, I want to make understand that India is an agricultural country and every farmers wants to know okay, what will be the yield going to be next year or next 5 years. Now suppose I say that I have a variable called yield of my farm. Okay, now I will say okay, my farm yield basically depends on what? I will say my farm yield they basically depend on monsoon. I will say my farm yield basically depends upon the labor cost, on the manure, on the water supply, my site from cell, and so on, multiple things. Or in another example, if I want to buy a flat in a particular area, so what the flat price basically depends on. So I can say the flat price basically depends upon the area, floor number, crime rate in that particular area, distance from metro, distance from school. Now these are the terms. Now in this particular two above two condition, you can find that we have one dependent and another independent. What is the dependent and what is the independent? Now you can see that the flat price which I am going to buy basically depends upon area, floor, crime rate, and DM, distance from metro and distance from school. Similarly, the yield of the farm basically depends upon monsoon, labor cost, manure, and water supply. But if I say that side from sale or water supply does not depends upon farm, that is fine. Means the dependent or the yield or the flat price are called dependent variable, and this independent variable can be termed as monsoon, labor, manure, and so on. So in this particular term, I can say my age is my dependent variable or an independent variable. So I will say I have age. So it will act as an independent variable. So I will making it as a green, and my salary, which is depending upon my age, I will termed as an dependent variable. Now, if I want to develop a regression equation based upon this, so I have a very small one that is called simple linear regression, that is beta naught plus beta 1 into x1. Now you will say what is beta naught and what is beta 1. Okay, and what is this x1? Now coming up here, when you analyze this particular chart or this particular result, so let me have a small diagram up here. So fine. So we will basically understand this. So I will have this just a minute. Okay, fine. Okay. Now if you say that somebody's age or salary, now I will be drawing this particular line, and in this particular line, I will be telling out what is beta naught and what is what. Okay, now can you see this particular line? You will find that it is a straight line which is deploying y equal to mx plus c. Now it will be much better in paint. So I will be coming to the paint one. Now fine. If suppose I say I want to develop a relationship between age and salary. So I will say that this is my age and this is my salary. Okay. Now what you want to do, on which you want to take age, which you want to take salary, you can define on your own. Suppose I say this is my age and this is my salary. Okay. Now you also know that on a definite age you will earn a salary. The minimum salary you will have a exact figure. किसी की सैलरी ऐसा नहीं है कि वो जीरो से स्टार्ट होती है, तो हर बार क्या होता है, एक बाय डिफॉल्ट एक इंटरसेप्ट होता है जो बेस सैलरी का होता है. तो सेम वे हियर ऑल्सो अगर हम इस ग्राफ को देखें तो ये ग्राफ एक स्ट्रेट लाइन को फॉलो कर रहा है. इसका मतलब इसके बीच में एक रिलेशनशिप है. देयर इज अ स्ट्रेट फॉरवर्ड रिलेशनशिप बिटवीन सैलरी एंड एज. Now, if I'm saying there is an intermediate relationship, then this particular value from the index is called beta naught. Okay. Now, if I say y equal to, if this stating a y equal straight line, I will say y equal to beta naught plus beta 1 x1. Now, here what is x1 and what is beta 1? Now, I was saying that I want to compute the salary when my age is 27. So, this is the age one. This is the salary one. This is the base salary, beta naught, and this is a coefficient of that x1. So it is a coefficient of x1. So now we are trying to figure out a relationship between a dependent and independent, and that is called regression. Now regression can be done in multiple formats. So there are multiple uh, algorithms, I can say algorithms for regression. There can be linear, there can be multilinear, there is lasso, digit, support vector regressor, decision tree regressor. Now there we can implement anyone, but here we have one dependent and one independent. So our linear regression will be something like this: y equal to beta naught plus beta 1 into the salary or the age, not the salary, the age. Now, when in this particular case, in case of flat, here we have multiple values, then we will not go with this. We will go with beta naught plus this beta 1 into area plus I have another intercept or coefficient of beta naught, beta 2 for floor number, and so on. So the equation can be different, but the base concept of linear line can be same. Okay, now suppose if I want to make you understand what is basically linear regression. So what it is basically linear regression is, suppose I make a straight line or I make a line curve using this point. So I am taking and I am going to make a line curve using this. So just let me have the line curve. Now this is my line curve. I will be taking this long range. Just a second. Let me have the data range from here. Okay, now fine. I have two curves with me. I have one line curve up here. Now, can you see that there is some similarities? Now within age, but it is not the age one I have not getting. So just let me remove this. Just a second. Let me take the regression only. So let me come to the data up here. Let me go to the data part. Let me go to the regression. Now this sort of regression can be easily applied in Excel. So here it will ask me the dependent value. So I will say I have a dependent value as this, not this. I will be calculating y. So I will be saying this particular thing as salary. This as x. So I will saying this. Now, if I don't want to go continuous, I want output on the same range. So I'll ask for the output window, not up here. In here, I will ask the output window. I want output to be up here. I'll be providing this as sales, and I will saying, okay, what I want the fit line plot. If you would want the residual plot, you can also go for residual plot and perfectly fine. Okay. Okay. Now I will have a shift soft outcome for that particular regression. And that regression I will be having for y equal to, it is saying beta naught will be something like this plus 1522 will be the coefficient for salary. Now, according to it, it is giving something like this, but I'm not following this particular trend, because if I'm going according to this particular trend, I am going to be a clear cut shot out of my way, because I am doing for R, I'm not doing for Excel. So I'll be coming up here on my that thing only, and I'm going to draw basically a very small figure out. Then we will moving down with R, how we actually do in R and what is basic result. So suppose मेरे पास एक जैसे ये डेटा दे रखा है, और किसी ने कहा कि मेरे पास एक अमाउंट दे रखा है, कुछ एक्चुअल डेटा मेरे पास दे रखा है, जैसे मेरे पास कुछ एक्चुअल डेटा है, इसके बेस पे मैंने कहा एक कुछ एक्चुअल डेटा मेरा यहाँ पर सबमिटेड है जो मेरी फाइल्स में दे रखा था. तो एक्चुअल डेटा सपोज करो मेरा यहाँ पर दे रखा है, यहाँ पर दे रखा है, यहाँ पर दे रखा है, कुछ यहाँ दे रखा है, कुछ यहाँ दे रखा है. ठीक है, अब जिस तरह से मेरा एक्चुअल डेटा दे रखा है उस हिसाब से आपको लग रहा है कि ये मेरे पास एक्चुअल डेटा है, तो इस वाले कलर से मैं कहता हूँ दिस इज माय एक्चुअल डेटा. इस एक्चुअल डेटा के बेस पे मैंने अपनी मशीन को ट्रेन कराया और उस मशीन ने इस एक्चुअल डेटा के बेस पे कुछ प्रिडिक्शंस करे। जो प्रिडिक्शन करे उनके रिजल्ट कहां पर थे, कहीं यहां पर थे। कुछ प्रिडिक्शंस के रिजल्ट यहां पर थे। तो आपका जो फाइनल रिजल्ट निकला, आपने कहा कि मेरी प्रिडिक्शन लाइन निकल रही है कि जहां से मेरी वैल्यू प्रिडिक्ट होगी, ये है मेरी प्रिडिक्शन लाइन। लाइन को देख के आपने कहा कि ये बिल्कुल लीनियर रिग्रेशन ट्रेंड को फॉलो करेगा, बिकॉज लाइन इज स्ट्रेट लाइन, इट इज फॉलोइंग द सेम कॉन्सेप्ट एज इक्वल टू y इक्वल टू mx plus c. But here we are not following this particular trend because the equation of this here is y equal to beta naught plus beta 1 x1. Okay. Now, if you are saying that this particular point is the, now this blue line point, where my blue line or my dot line is called predicted point. Now you have one actual point and one predicted point. ये आपका जो एक्चुअल मॉडल के अंदर प्रेजेंट था, उसी सिनेरियो पे आपके कुछ डेटा ने भी प्रिडिक्ट करा। अगर कुछ ऐसा होता है तो हमारे पास कुछ डेटा ऐसा आता है। इसका मतलब अगर इस एक्सेल में आऊं तो ये आपके पास सैलरी जो थी वो एक्चुअल में थी, जो एक्चुअल हमारे पास गिवन थी। बट हमने मशीन लर्निंग लगाई और मशीन लर्निंग को भी ऐसा ही डेटा दिया, तो हमारा जो मशीन लर्निंग ने भी कुछ प्रिडिक्शन करके दिया। तो शायद मशीन लर्निंग 100% कभी होती नहीं है और हो भी नहीं सकती है, क्योंकि कुछ ना कुछ वेरिएंस हो जाता है डेटा और प्रिडिक्शंस के बीच में। थोड़ा बहुत चेंज आएगा, या तो ऊपर आएगा या थोड़ा बहुत नीचे आएगा। तो सपोज करो आपके कुछ डेटा ने कुछ रिजल्ट्स ये प्रिडिक्ट करके दिए। आई डोंट नो व्हाट इज द रिजल्ट, बट जस्ट आई एम ट्राइंग टू मेक माई पॉइंट मोर वैलिड कि आपके कुछ रिजल्ट ऐसे आए। ये आपका एक्चुअल डेटा था, इसके बेस पे ट्रेनिंग हुई और आपको यही डेटा पे प्रिडिक्ट करने को कहा कि अगर ऐसा ही कुछ होता तो आपके पास क्या पॉइंट आता। तो आपके पास पॉइंट होके क्या निकल के आया, आपके पास ये पॉइंट निकल के आया। नाउ आपको पता है कि ये आपका एक्चुअल डेटा और ये प्रिडिक्टेड डेटा है, इनके बीच में जितना डिफरेंस होगा वही आपका एरर होगा। तो अगर मैं इस पॉइंट पर आऊं, इस फिगर पर आऊं, इस फिगर में आप ये देख पाओगे कि जो एक्चुअल डेटा और प्रिडिक्टेड डेटा के लाइन के बीच में जो डिफरेंस है वही आपका क्या है, एरर है। दिस इज टर्म्ड एज एरर। और आई कैन से आई हैव y एक्चुअल, आई कैन से yi minus yp predicted. Now that term I can define as error. और किसी भी मशीन लर्निंग एल्गोरिथम्स का, और if any of the machine learning algorithm approach is to minimize this error. If suppose my predicted value is 100 and my actual value is also 100, then I can say my accuracy or my answer is 100% accurate. And every machine learning is trying to do it at 100%. So what is the major objective of linear regression? To optimize this error. Now how it basically optimize this error? तो अगर मैं लीनियर रिग्रेशन की बात करता हूं, जो लीनियर रिग्रेशन होती है गाइस, तो उसके अंदर हम क्या करते हैं, हम जो टेक्निक लगाते हैं होता है OLS, ऑर्डिनरी लीस्ट स्क्वायर। ऑर्डिनरी लीस्ट स्क्वायर इज बेसिकली ट्राइंग जैसे सपोज करिए मेरे पास एक इक्वेशन है y इक्वल टू, इफ आई से बीटा नॉट प्लस बीटा 1 इनटू आई से x1. नाउ सपोज आई से x1 is my age. You also know that y which is beta, y which is going to be the predicted variable, is going to be predicted. Okay, y is the predicted variable. I cannot change the y because I can change the y using beta naught. Now beta naught and beta 1 values are changeable. Okay, and x is constant. Now suppose I say x is constant and I say that I have to predict y when my beta naught plus beta 1 into what my age was 27. और इसका जो फाइनल आंसर आना चाहिए था, एक्चुअल डेटा के अंदर इसका दिया था कितना। अब सपोज आई से 37, आई कैन से नॉट 37, आई से 30,000। एक्चुअल डेटा में इसका जो सैलरी दी थी 30,000 दी थी। अब 30,000 के कितना करीब ला पाऊंगा उसको कौन डिफाइन करेगा, ये जो बीटा नॉट की वैल्यू होगी और किसकी वैल्यू होगी, बीटा 1 की। तो जो ऑर्डिनरी लीस्ट स्क्वायर होता है लीनियर रिग्रेशन में, उसका मेजर ऑब्जेक्टिव क्या होता है कि बीटा 1 एंड बीटा नॉट या बीटा 2, बीटा 3, बीटा 4, उनकी वैल्यू को ऑप्टिमाइज करना। ऑप्टिमाइज कैसे करना, जो आपके पास ये जो टर्म आया है एरर का उसको मिनिमाइज करना, बिकॉज व्हेन द एरर गोज ऑन डिक्रीजिंग, द एक्यूरेसी और द रिजल्ट और द distance between this data distance and this data distance become decrease, means the accuracy will increase. So my major objective is to dwell this part only from my case study, or that my case study which we were doing in R is also focusing on that. What is the case study in this particular scenario? So we will be applying the case of linear regression on this. How we going to apply this? So we will say that our topic or the case study is, we want to we want to find or predict the online sales made by customer. That is our case study for the day. So I'm going to predict what will be the online sales based upon the customer features. Or what are the customer features? These are the customer features which we can see in data. Age, since login since last days, purchase made, job type, and so on. Now in this term, I have to make my dependent variable and independent variable separate. How will I say? I say that dependent variable, I want to estimate the online sales. So online sales column will be purchase made. So I'll be coming here and say data dollar. Now this is purchase made column is my online sales one. So I'll be saying this is my dependent variable. So I'll be coming as dependent, and all the rest is my independent. So I have to develop a linear regression or a relationship. I have to develop a relationship between I have to develop a relationship between my purchase made and all the left out columns. How will I will be doing, or how will I doing? So I have to take certain measures for this. Now if I'm doing machine learning, first of all I have to train my machine. But the what is the major scenario with me? I have a data set. Okay, and in data set there are 325 rows. What is was mentioned up here? Now in machine learning, in supervised, I have to train the machine also and test the machine also. And for training and testing and for validation, I need three data. I'm not considering validation. I'm only going for training and testing. So for training and testing, I need two separate data. So I don't have two separate data. I only have one data. So I'll be saying I will be separating my data into two parts. I'll be taking 70% of data into train and 30% into test. Now this percentage is not fixed. Some can say 80-20. Some people always take 75-25. Some can say 60-40 can also be. So you can take, but maximum amount of data you should give in training, not in testing. Okay, now we will coming to the R and we will see how we actually split the data into two parts. So we will use certain libraries. We will perform certain use of libraries, how we actually treat the data, how we divide the data. So for that data, we will take some of the libraries or package. So how we actually import packages in R. First of all, if I want to import a package, so I have to first write import packages. Within that packages, I will pass car. I will control and hit enter. So I will say, yeah, I want to restart the session. So just a second, it is just restarting up. And here I will say library. It will just take 1 minute, not max. Now I will write library. Within library, I will pass the library name. I'll pass car. I'm going to hit enter. Okay, fine. Now our library has been imported. We'll wait for a while. Okay, it's saying it is no library could not find. So I will first import the library. Library will be going to install. So can you see that the library is going to install? When it is installing the same way, it will be coming up here. It will be downloading the library, required library successfully imported. First of all, it will be unpacking all the things which are in that particular library. So it has, I think it has unpacked itself. Yeah, it has unpacked itself. So I'll be now importing the that particular command, that is lib library car. So I'll be importing. Just a second. Okay, the spelling mistake, I think. Now fine. I'll importing this. So it is loading the required packages. I have to import car. There are some tools as car tools. I have to import this also. In car tools, I have to import the library in this particular format. So first of all, let it download that one. Fine. Car tools is also okay. Now, if I want the data to be split or separate out, if I want to split the data, I have to split. I have to split the data randomly rather than repeating one element or the other. Now, you can also prefer the bootstrap sampling here. You can also refer bootstrap sampling, but I'm not going with the bootstrap sampling. I will be referring the sample. So I will first select the seed off, and you can find seed, you can extract seed, or you can take the seed value to any. It will help you to take random sample from it. So okay, now fine. So I'll be coming up here and I will say chat.seed. So I will first of all make a SPL variable. For that I will say sample. Within sample, I will say I want to sample dot split. I want to split this particular sample data. What data? I will say I have taken a data and my data is in data name. So I will say data. Within this particular data, which column? I have to define my dependent column. So my dependent column is this, comma. I will say split ratio. I have a split ratio. What split ratio? First of all, in training, I want 70%. So I say 0.70. For training, I will be submitting some separate data. I will say subset. I want the subset of this. And within subset, I will pass data. I have to extract data from past, comma. I will SPL equal to true. SPL true means, here SPL true means that I am taking that 70% of data into this. And when I will say test, I will take the subset same. And here I will pass data and I will pass SPL equal to false, which means I am not taking the top one 70%, I'm taking the last one. So when I'm going to click over this, click over this, click over this, click over this, let's see the dimension that it has split into the data or not. So I will say print dimension for training data. So I will print the dimension and you can find, yes, what happened, just a second. It has not split. Just a second, let me check. Okay, fine. Okay, I think they have created up here. Okay, SPL is created. Okay, here I have not equal. I have to compare the value, double equal to true, double equal to false. That is a major issue. Now fine. And you can see now they have perfectly divided the data into two parts. So I can see the dimension for test also. So this is my test data dimension. 227 column rows, 98 rows. There were actually 325. If I take the 70% of 325, it will near about equal to 227. So fine, my data has been completely divided. Now I will going to take or build a linear regression model. I'm going to take a linear regression model in R. In R language, first of all, I will make a model. First of all, I will say this is my model 1. Now, I will say I want to apply a linear model. So I will apply a linear model. I will say LM, linear model. And this linear model, I will say I want to apply my linear model based upon data. Now, which data I will say I have purchased made. I will come up here, give this symbol, say dot, comma. I will say I will take the data equal to, I will train my data based upon this, and I'm going to run this, and my one of the model will be created. I will say model one, and I will take the summary for this. I will say summary, fine, and fine. When I'm going to see the summary, you will be very amazed to know that the model has completely made of itself, and in that particular model you can see some of the variable which will have this value, star value with them, and some of them will have unstar value. Now these star value are termed with respect to the p values. P value basically refer to the confidence. Confidence means suppose there are some variables in the columns which do not have any impact on my predicted output. For example, suppose I take roll number and student name and his passing marks and its qualification. Now name or pass or name or qualification or thing doesn't depends on passing marks. Or if I say student is going for an online exam and his roll number is 1, do he score 90% or not? So roll number doesn't have any impact. In the same way, there are multiple arguments which do not have impact on that. So what we basically do when we basically drop one element or one columns based upon the p value. Now what is p value? We will only take the column which have p value less than 0.05. Why? Because our model has been built on 95% confidence. Model is at 95% confidence. That's why we are taking p value less than 0.05. If the model was is at 99% confidence, then the p value we will be looking for less than 0.01. But as the model is on 95% confidence, so we will be looking for the p value which are less than 0.05. देखिए यहाँ पे 0.05 के लिए उसने क्या डिफाइन करा है, डॉट, कि ये सबसे आखिरी वैल्यू है. इसके ऊपर वैल्यू जाएगी हम उसको नहीं अज्यूम करेंगे. तो बेसिकली आप कहां पर जाएंगे, 1 स्टार की तरफ. यहाँ पर आए आपने, यू विल फाइंड दैट एजुकेशन in secondary post doesn't have any significant impact because its p value is more than 0.05. So what will be my major objective? When I will be developing my second model, I will not consider this column in my second model. So how will I see that what will be my formula for taking this particular model? So in order to take the formula, I will be coming up here and I will define second model. I say model 2. Within this, I will pass, I say I want to develop a linear model. I will have to define a formula. What will be the formula? So I'll say formula. I will define here equal to, I will paste Control V. I will say this. I have to assign this symbol directly say that purchase made equal to, I have will say age is my column, plus, and I will be defining all the formula. Means I have a formula up here, so I will be coming down and I will say okay, this is my column. I will say this column as, I will say copy. Basically, I am just adding all the columns which are available with me. Regarding only I will drop few of the columns. What column I will be dropping, I will be telling you, don't worry. So though this will be just a second. Fine. Now this is the output. So what I will be doing, I have a lot of we don't have much time. So what I will be doing, I will be copying some of the code from another source code. So I'll be taking some help from here. So I'll be copying this. I'll be copying this and I will be pasting this up here now. Fine, where it was. Okay, we are doing this now. If suppose I have this term, I will be taking some of the things like, suppose I have two things like I have stock price. Say I have stock price, and within stock price I have this. Now stock price is also there, and stock price basically depends upon country value, country money. If I say, just a second, I say there is a country money, and I have value for that. Okay. Now, if suppose I say stock price basically depends upon country money and value. Now there are two variable. Now this can be termed as a dependent variable on which my actual this particular value is depending upon these and these. Now what I want that these two values should not be interdependent on each other. I don't want that country money should affect value or value should affect country. So in that order, we will first of all see the VIF for that. So how we actually see the VIF? We can come up here and say VIF can come up here, and I can directly say variance inflation factor. VIF stand for variance inflation factor. Now when we say about VIF, you can find, just a second. So it is saying model 1 is not defined, so I have defined with some other name. I have small name as model 1, so I will sim. You can see that some of the columns have VIF greater than 10. When I have VIF greater than 10, which means that column is basically irrelevant for us. So we don't take those columns which have VIF value greater than 10. So one, my condition is when I have VIF greater than 10, those columns are irrelevant. How to remove those columns? So I will be removing those columns one by one. Meanwhile, when I was seeing the summary for that, you will see that secondary education and secondary graduation in this particular education column both have VIF greater than 10. Secondary education and secondary grade both have value greater than 10, and by the help of p value we can see that those particular columns are insignificant also. So we have to remove first of them. So first of all, we will be taking, I will be coming up here and I will be saying that I have to remove that one. So I'll be coming up here, I will copying this particular formula. Now that formula doesn't means that I will be taking some different code. What I have done, I have only given the name, and what I have defined up here, I have only removed that particular column. Which column I have removed? I have removed one of the column that is called education secondary. One column we will remove with the help of p value maximum. सबसे ज्यादा p value इसकी थी क्योंकि 0.05 से सबसे ज्यादा इसी की थी, इसलिए इसको रिमूव कर रहे हैं based upon training data. Build our model. So I will say I have defined a model up here. I will say model 2. Now here also I will say model 2. Coming up here, I will say model. Finally, my model 2. And in this, you can find when, as soon as I have removed what? As I have removed that particular one column, my whole data has become unaffected on each other. Means I have removed or I have reduced the multi-collinearity term. Now, basically, what is multi-collinearity? If suppose two independent variable becomes interrelated to each other, they may hamper the result. So in order to reduce multi-collinearity, we basically check the VIF. Now, when we see the summary, we find that when previously this particular education grade was irrelevant, but now it has maximum relevancy over it. That's why. So in the same way, we basically do all the things. Now we will be removing which column? We will be removing this retire type column. So I'll be taking that particular model from my code file. So coming up here, copying this code file I made for this particular session previously only. So I have model 3. So I'll be going with model 3, VIF for model 3, and you will see that I have these column which I will be taking from. Now, if you want to have a look on the model summary, so you can directly say summary of model 3, and finally, not model 3, capital model 3, because there's a case sensitive language. model 3, and you will find that all the columns now have relevancy except this particular column. And this particular column should also be removed from the above. So what I will be doing, I will taking this model 3, coming down, control V. I'll be making this as model 4. This is also as model 4. This is also as model 4. And I will be removing this column, unemployed job type. So I'll be removing this column because I don't want to make any formula or any status formula using this column. So I'll be running this and running this. Now you can see all my columns are relevant because all the columns may have 2 star, single star or 1 star. Not even one column has p value greater than 0.05, and when the p value is less than 0.05, which directly means my all column has some relevancy. Now this data means what I have done up here, I have not done any kind of training. I have only make my model more important with respect to features. What I have done, I have make a combined file based upon these type of features. So now these features of my data are more relevant than the other feature. So what I have done, I have made a model also, and I have done feature selection also on the same path. I have done feature selection. Now when I will be going to take the data for some sort of analysis, I will only take this data for me. I will not take all the data. So if I'm going to take the data from the testing part, means the T part, so what I will be going to take. So first of all, let me have some libraries. So these are the basic libraries which we are going to have. I have lm test, and so first of all, let me import the library lm test. And while importing, this is for installation install.lab packages, and this is for basically importing the libraries. Where in Python, if you are working in Python, if I say if you are working in Python, you import something like this. You like import and library name. Or some people say also like this, from lib name import star. Now this code can be relatively in that particular field. So I'll be coming here. I have done two or things. No, fine. I'll be going up here, coming down. Now I will see my test data, and I'm going to load this, and finally we are about to reach the end of this particular model. Now coming up here on this particular thing, now I'm ready. When my model is okay, when my model is fine, when my model is okay, it is trained. Now I want to test it. I'm going to test it. I will be taking the testing data. So first of all, when I see the testing data, I will find the testing data looks something like this. Testing data looks something like this, and it is very small data, but it also contain all those columns which are irrelevant. So my first task is to remove all those columns. I know the column names. So what I am doing, I am removing the columns name from here. I am taking the actual data which I have to predict and then compare in the actual one. Then I'm taking the head of the column, and here what I'm doing, I have taken the all the data which I am going to test. Now this is my independent data for testing. I will be predicting some dependency over it. So what is the dependency for that? What I will be doing, I am taking model 4 because my model 4 is what? My model 4 is my final model which I have made for training. And I will be predicting some of the values by model 4. I will be saying LM, I will be predict LM, I will predict my overcast value of test data based upon this particular test data, which only contain the independent variable, not contain the dependent. I will say predict. So I'm going to run this. It has predicted some data, and what is the prediction? Predictions are here. So you can see that somebody has done the prediction. Now what I'm going to say, I will also compare this particular data with my actual data. Now, what is my actual data and what is my predicted data? Let's see up here. So I will say view, or if I don't want to see view, I can directly say this is my actual data. Just a second. I have not, I think, I have not run this. Okay, I have not run this, so I have to run from this, up from this. Just a second. I think I have missed one line, and that one line can cause a whole error in this. Now, I have to run my whole code from the above because I have missed one line that has hampered my whole code. Column name. Will not take much time. Just a second. Okay, so we are up here with the test data. So I'll be taking the test data. I'll be saying actual, and I'll wait for a while. Let it run. So first of all, let's see the head of the actual. I've taken the actual data based upon which I will be some sort of predicting. So I will say actual data. Actual data is coming to be null. What happened up here? Just a second. Let me predict something now. No issue at all. So on the basis of these thing, on the basis of these data, signed in since last days, marital status, education, metro city. What I want to predict, I want to predict what will be the sales amount. So when I will be going to predict, I will be saying based upon the test data, what is my test data, which is be shown up here. So you can also view your test data. So I will say view.test. So this is my test data. On the basis of that, if suppose I am living in metro city, if my graduation is there or marital status is there, since last days is there, then what will be going to my purchase made from the website. So what happened when I say predict, I will say predict and I will click on this. Now you can see that I have some sort or some other sort of data up here. Now these are my prediction. Now prediction result can be given up here. Now when I will be coming down, just a second, when I will be coming down, I have another code which is called R square. Now what is R square basically called? Now what is R square basically called? So I have turned, or if I want to evaluate my model, how my model is good to consider or find out the predicted value, I will term that particular model with the help of R square. So in logistic regression, oh sorry, not logistic, in linear regression, we basically find R square to evaluate our model. Basically R square means what? So if I'm coming to the paint option, I'm coming to the paint option and I'm coming up here and up here, fine. This is also here, it's fine. Now I have some of the data points which are being defined up here as this. So suppose I have data point like this, I have a data point something like this, I have data like this, I have data like this, again data. This is my actual data. And based upon the actual preference, I have some predicted data. So some predicted data is this, and this. Now what R square actually means? R square means the separation or the distance between actual data and predicted data, means the separation ratio. When the separation ratio value actually lies between 0 and 1. 0 means we have a lot amount of variance in data, means the data will be something like this from the actual point of line when the value of R square is equal to 0, which means our model is worst, we cannot predict anything from the model. But when the value is tending to be equal to 1, which means the actual point and the data point is having a very less gap between them, means we can easily figure out what will be our predicted value. And in our model, what we have made, the R square value is 0.83, which directly means we can prefer 83% out of 100% from the data. Means if I have 83 points, I can, if I have 100 points, I can figure out 83% of data correct, and rest somewhat around 90%, or I can say 19, not 19, I can say near about 15 to 18%, near about. It's not wrong, it's about near about, and wrong and near about is something different. Okay, now that is complete scenario in R programming, how we actually make models in R. Nowadays what happened, R is become little bit complicated if you if you compare it with Python. Okay, so I'll be not taking much more time, we will having a break soon, don't worry, but I want to like to show this particular whole scenario in Python. Okay, it will not take more than 10 or 12 minutes in Python. Because Python, why Python in not more than 12 minutes? Because Python provides you a whole helpful libraries or a bunch of libraries to do it. So I will be minimizing this. I will be opening Jupyter notebook. So I have Jupyter notebook opened with me. Coming up here, I have a home Jupyter notebook. So let me open my Jupyter notebook new window. I'll be opening a new file. Now this is in Python. I'll be working in Python. So if I'm working in Python, there I have to import all the libraries of R. First of all, I have to import the libraries of R. Then I have to install it. Here you don't have to worry about installation. Here you don't have to worry about the things. Now we will be one project we have seen in R, one case study we have seen in R programming, that is linear regression. Now when we will be moving down towards logistic regression, we will be seeing the work in Python. Okay, so now when we are talking about this particular case, that is Python, we have seen one of the case study of our, that is linear regression in R, and this we will be seeing in Python. So we will be going down with logistic regression in Python. Or if you want that also in R, just let me know. I will be doing that also in R, no issue at all. But I want to show you more that in R and Python how we can compare. The major thing is that only the modules and the code is also more easy of Python as compared to R. So now if I'm working in Python, now this is my IDE in Python. It is more attractive than R and more useful than R. Now suppose if I want to make a report, general report in Python, so I can easily write a general report. So I can say this is my, this will be my data cleaning in Python. I want a cell. Okay, now first of all, if I want to import the data, I have to import some libraries. Some of the libraries which are dealing with the structure, that are pandas as pd, these are called alias name. I'll import numpy as np. I import some of the visualization library as matplotlib, pyplot as plt. Control enter, I'm fine. I will be importing the data. Here the importing of data is very fine, very clear. I will write, I want to read a CSV file, so I will say CSV. Now I will be minimizing this. I have to import a CSV, so I will be coming up here. I'll be taking this data set as CSV. So now I will be coming up here, dwelling with CSV. I'll take this path as this, copy this, coming to my Jupyter notebook. I will be maximizing this so it will be more visible to you. So just a second. Okay, fine. Now I will be just pasting the path. I have given a raw path. I don't have to change the symbol. I don't have to symbolize this. Control enter. And when I will say data.head, it will provide me the top 5 rows. And finally, I have with my data. Now this particular case study, we will be looking for the logistic regression in the next second half. Okay, and I will be loading this particular data. I will be moving whole complete things like data visualization, data pre-processing, data cleaning with respect to a finite model in of logistic regression in Python. Now, if I talked about data cleaning, now here also you have some data. some data as shown in the given figure. Now in this data, you have name, you have gender. Now these name and gender. Now, have you heard about that your name decide that whether you will predict something correct or not, or whether you will pass your exam or not, or whether your salary will hike based upon your name, something like that. If the company is taking that all the people who belong to name A will get a 50% hike, and the name all the people who belongs from D or Z category name will not get a salary hike, will have a deduction. That is not completely fine. So what happens sometimes, our data contain such rows, sorry, not such rows, such columns, which are not relevant. Now, in this particular scenario, this particular case study doesn't have this particular name as irrelevant. Now, name is not the relevant column. So if I want to drop a one column only, I will say data.pop, and with pop, I will say name. Now you will find that I have dropped my name column from my data. So as when I come up here, I will say, yes, I have, so sorry for that. So I will say data.pop. Let me again done this. What happened? I have saved the data into a variable. I don't want to do that. Now fine. Now, can you see I have just dropped the name column from my data because it was irrelevant. Now, this particular case study is of, it was a competition on Kaggle that was Titanic dataset for classification form of problem. Now, why classification of problem? Really looking down towards classification of problem. But why this case study I have taken? I have taken this case study because this is a fundamental case study. If you want to learn fundamental case study to understand a logistic regression. I'll be showcasing this same case study in R as well as in Python, but maximum coding we will be moving down with Python, and minimum coding we will require in R. Now, why we are saying this is a classification problem? Okay, so if I consider classification, so I have to come into this file, Excel file. So here I will be dealing with classification sort of problem. Now, what is classification? Classification is also considered into supervised form of machine learning to SML. It is considered under SML. Now, if I'm saying classification, I am directly saying that I am trying to figure out some form of class or some form of category. Now, and if suppose my one of the phase category is I want to predict whether the person is suffering from COVID-19 or not. Now here what will be the case? Now here COVID-19 case will be, here either it will be a positive or here it will be a negative. Now here we have only two kinds of case. Now I can say that when I want to predict in form of category, in form of class, in form of binary output, then I will apply classification problem. Or my case study, I want to predict a survival of person in Titanic disaster. Now you also know that the disaster can have two things. Either you will live or you will be dead. So the same way I will be applying classification. Now each algorithm selection is based upon the problem statement. Now if suppose I will say I want to predict the weather for next week, and in weather I want to predict temperature, so I cannot go for classification. I can't and use classification. Why? Because it is form of a regression line, because it is not a classification problem, because here output value is in a continuous format or continuous data. When my data or my predicted value is in form of class, I will go for classification, and when my predicted data is in form of a continuous variable, then I will not go for this, I will go for regression. Now, this is the major step why we have turned down towards classification. And in classification, we have multiple algorithms. So today we are going to go with logistic regression because the base concept of logistic regression is being coming from linear regression. Basic concept is same. And what is the basic concept is same? Now suppose if I have positive and negative case or live or dead. Okay, so I'll be coming to my this particular Jupyter file. Now if I want to do some sort of analysis, first of all I have to convert or find missing values or convert this or pre-process it. Now here pre-processing is pretty fine because Python community is providing a very helpful and of libraries. Here we don't have to think a very lot okay, what I will be do. For suppose I want to see that is there any missing value, I will say data.isNull.sum. Now here directly it is saying okay there is a perfect count for that. Okay, in age column I have some missing values. Okay, let's fill the age column. So I will say data.age. In that particular age column I want to fill the age. So without seeing the data distribution I'll be filling with this median. Because why I'm going with median, I have a very clear cut instruction from my own side. Why? First of all, let come and see why I'm going with median. So just a second. So can you see, suppose if I'm making just a second, not this, I'll be taking this. Now I have suppose I have a simple structure like this. Okay. And suppose I have a simple structure like this. Now I have two structure with me. One is skewed, another one is UDF. If I go and cross check in the UDF column, I find that mean double equal to median. And when I'm going with the some skewed value, I have to fill the missing value with median. So if I take median both side, if I take in this, if suppose data is UDF and I take median, then also no issue because mean is also equal to median. But if my data is right skewed or left skewed, I can take median value. So that's why what I'm saying, you can take median by folding your eyes. Okay, now I will say fill any. I want to fill this particular column, this particular age column with the median value, comma in place equal to true. Now I will going to running this and I will going to run this. You will find my all columns are being treated. All my data has been filled up. Now if I want to label my data, label my text data, I'll going to run, I will be saying data. I'll be first of all I have to import some of the modules. So I will write from sklearn dot pre-processing because I have to process my data. I will say import label encoder. I'll make a variable for label encoder class variable and I will say I want to transform these column. Gender one column, this gender one column, copying this, pasting here, and I want to change my embark column. Now embark is something where when the Titanic has started its journey, Titanic has stopped or they have the ship has stopped to some of the location like Southampton, uh, Queensland and many more. So this is the embark column which also contains category type of column. When I'm going to run this, you will find that I have already labeled or converted all the data into form of numeric values. So I'll wait for a while and meanwhile when the code is running, okay, I have got some error. What is it? It is saying object doesn't support item assignment. Okay, just a second. From sklearn.import label encoder. Just a second. Let me check the code first. Sometimes code happens. Let me check this. Okay, it's fine now. Label encoder. Fine. Let me debug one line. So let me find. Let me debug this. Okay, so I am having within this L equal to L dot fit transform. Okay, let me check the modules or data for L. Here is fit transform. Yeah, I have fit transform this in. Okay, I got the error. I don't have LE up here. I have to define data up here because LE is not the column where I was looking for. Now it will be coming fine. Now you can see that I have transformed my gender into numeric and embark into numeric. Whereas if I'm going with R, so I will be moving down here, Ali moving down towards R, and I will be moving down towards the same case study as up here mentioned here. So just a second, let me close some of the blocks which are not required for us. Don't save. Okay, fine. So as you can see, I have some of the case study with me. So now in this particular column or in this particular case study, we are doing the same stuff. Now what I'm doing the same stuff. First of all, I'm clearing the environment. After clearing the environment, I'm just reading a CSV file. After CSV reading a CSV file, what I'm doing, I'm viewing the data. After viewing the data, I'm seeing the summary for that. After seeing the summary, I know there is some missing column in age. So what I'm doing, I have to extract that particular mean value and filling the mean value. Whereas in Python, I have already defined a method for it. Now, in R, you can see that I have a very hectic programming thing for converting those to numeric. Female to this, S to 1, C to 1. Whereas in Python, I only have to write these two lines of code and they have confinedly transformed them into labels. Now that is a powerful source help by Python, and Python has become more useful in industry as compared to them. Now, if I'm saying in R, first of all, I have when I have to convert it or when I have converted those to dummy, I have to first concatenate the dummy variables. Then I have to explore the outliers. Whereas there, I will be exploring outlier in a very specific format. So I will be going to give you a short break. We will have a quick short break of near about 25 minutes. Then we will going to connect back
Okay, मैं
and
वो
we will going to connect the second session for that.
thank you, sir. So participants will be having lunch break up to 2. I think we'll start at 2 o'clock, sir.
Yeah, ma'am.
Okay.
We can start by 2 till 2:05 also. No issue at all.
Okay. Okay. Sir, let us make it 2:15.
Okay, sure, ma'am.
Okay.